In question 1, I'm given that 3/10 of the total amount are changed into euros. So I'll start by finding 7/10 of 20,160, which is 14,112, and this is changed into 3 different currencies. Now, since the ratio is 9 to 5 to 2, this has a total of 16. So for dollars, I have 9/16 of 14,112, and for francs, I've got 2/16 of the same amount. This will give me $7,938 and 1,764 francs. And all I need to do is find the difference by subtracting, and this will give me 6,174. For question 2, to find the modal class, I need the highest frequency, and this is for a speed between 70 and 80, so that's my modal class. For part B, I need to work out the mean speed. To do so, I will need to find the midpoint of each category, and then I'll need to multiply this by the frequency. So let's create 2 new columns. Now F is the frequency column, X is the midpoint. So the midpoints are 45, 55, 65, 75, and 85. And for the fx, I'll multiply 10 by 45, that's 450, 16 by 55, 880, and so on. The sum of the last column is 5,310, and the sum of the frequency column is 80. This is also given by the question. So to find an estimate for the mean, I will divide sigma fx by sigma f. So 5,310 over 80, and this will give me 66.4. In question 3, I have this container full of water, and between 10:30 and 12, water is being removed at a constant rate, and the level of the water drops by 20 centimeters. So if I separate the water that has been removed and the water that is still in the container, then I get the following. The blue shape is a cuboid with dimensions 125, 30, and 20, while the red is also a cuboid with dimensions 85, 125, and 40. So I can work out the volume of the water removed and the volume of the water remaining as follows. For the water removed, 30 by 20 by 125, which gives me 75,000 cubic centimeters. And for the water remaining, that's 85 times 40 times 125, which is 425,000 cubic centimeters. Now, the water is being removed at a constant rate. So if I want 1.5 hours, that's between 10:30 and 12, for 75,000 cubic centimeters, how much time do I need for the remaining water? So I can cross multiply, and X will be 425,000 by 1.5 hours over 75,000, and this will be 8.5 hours for the remaining water, which means from 12 I will add another 8 hours and 30 minutes, and I will go up to 2030, that's 8:30 p.m. For question 4, I'll start by listing sets A and B. A has all the odd numbers, so that's 21, 23, 25, 27, and 29. B has the multiples of 3. So this is 21, 24, and 27. So A intersection B are all the common, those elements that both in A and B. So these are 21 and 27. And A union B includes all the elements that are either in A or B or both. So I get 21, 23, 24, 25, 27, and 29. In part A of question 5, I'll just take out a common factor of 5y to the power of 3, and then I'm left with 3y plus 4u. For part B, I will cross multiply, so 4 times 4 minus 3x equals 5 minus 8x. Now I will expand 16 minus 12x. The right hand side stays the same. I will collect all the x's on the right, so I've got 4x, and all the numbers on the left, I've got 11. So x is equal to 11 over 4. For part A of question 6, I've got 2.84 times 10, and then I've got 7 zeros and 2 digits for 8 and 4. That's a power of 9. And then for part B, I'll need 4 zeros at the beginning, so 0.000 and then 2, 5. For part A, I've got an increase of 3.5 each year. This means that the multiplying factor is 103.5 out of 100. As a decimal, that's 1.035. So my new value, the value of the investment at the end of 3 years, will be the initial value, which is 40,000 times my multiplying factor to the power of 3, because I have 3 years, and this will give me 44,349 to the nearest integer. In part B, I have a decrease by 6.5 per year, so my multiplying factor will be 6.5 out of 100, less than 100, so that's 93.5 out of 100. As a decimal, that's 0.935. So the value of P, which is the initial one, will be multiplied by the multiplying factor to the power of 1, because that's for 1 year, and this will give me the final value. So to find P, I will just divide the final value by the multiplying factor, and this will give me 32,600. In question 8, this shape is made up of 2 semicircles and 2 straight lines. The blue semicircle has a radius of 7, while the red one has a radius of 7 plus 2 equals to 9. And just as a reminder, the formula for the circumference of a circle is given by the formula 2 pi r. So for the inner arc, that's the blue one, I have 2 pi r, which is 7. And because the whole circle, it's half of it, I will divide by 2. This will give me 7 pi. And for the outer arc, I have again 2 pi r, but this time with a 9 over 2. That's 9 pi. So the perimeter is given by 7 pi plus 9 pi plus the 2 straight lines, which are 2 meters each. So this will give me 16 pi plus 4, which comes out to be 54.3 meters. For part A of question 9, the power of 4 applies to all terms. So I have 2 to the power of 4 times x cubed to the power of 4 times y to the 5 to the power of 4. And this will give me 16 x to the power of 12, y to the power of 20. In part BI, the two factors are x plus 9 and x minus 4. Hence, in part II, the two solutions are x equals minus 9 or x equals to 4. In question 10, I need to find the perimeter of this triangle. Consider the upper right angle triangle, triangle ABD. Let's extract this triangle and find the sides A and B first. So sine of 65 is equal to opposite, which is 16, over the hypotenuse, which is A and B. So A and B is equal to 16 over sine 65. This will come out to be 17.65 and so on. Then I will also find AD. I will use tan of 65, which is equal to opposite, that's 16, over the adjacent, that's A and D. So A and D is equal to 16 over tan 65. This gives me 7.46 and so on. Hence, the whole side, the vertical side, AC is 2 times 7.46. AC comes out to be 14.92. Hence, the perimeter is 17.65 times 2. A and BC are the same, plus the vertical side, that's 14.92, and this will give me 50.2 centimeters to 1 decimal place. In question 11, I have this cumulative frequency graph, and in part A, I need to find the median. So 90, which is the total, divided by 2 gives me 45. So I need the 45th observation. So I'll go to my graph, go on the vertical axis, locate 45, and then read the corresponding x coordinate. So the answer to part A is 146. For part B, I have bags sold for 3.75 and the total amount is 93.75. So 93.75 divided by the 3.75 per bag will give me 25, and these are large bags, and large bags are bags with a weight greater than D. So I'm going to go to my graph now, but before going, I need to calculate 90 minus 25. That's 65 bags that are not large, so I'll need the 65th observation from my graph. So let's zoom out a bit. So 65th observation is the following. So from my graph, I get 151, and that is the final answer for part B. For part of question 12, the common denominator will be x minus 2, x plus 1, and then I'll multiply 4 by x plus 1 minus 3 times x minus 2, and this is equal to 4x plus 4 minus 3x plus 6. Denominator stays the same, and this simplifies to x plus 10 with the same denominator. For part B, I'll start by expanding the two brackets. So 2x, and then I get x squared minus 3x minus 5x, so that's minus 8x plus 15, and then I get 2x cubed minus 16x squared plus 30x, and this is my final answer. For part A of question 13, I'll use the following formula. Let's plug in the values. So I get minus 4 minus 8 in the numerator, 9 minus 5 in the denominator. This comes out to be minus 3. Then in part B, the gradient of line L is equal to minus 4. So to find the line that is perpendicular to L, I will flip this. So instead of 4 over 1, I get 1 over 4, and instead of a minus, I get a plus. For question 14, part A, I need the probability that Dean wins both games, as the probability he wins the first one times the probability he wins the second one. So that's 0.6 times 0.9, which comes out to be 0.54. Now in part B, I need the probability that he will win exactly one of the games. So that's the probability he will win and then lose, plus the probability he will lose and then win. So I need a win followed by a loss, or a loss followed by a win. So I get 0.6 times 0.1 plus 0.4 times 0.25. This comes out to be 0.16. For question 15, note that V is equal to 9.6 to 1 decimal place. So V is between 9.55 and 9.65. U is equal to 3.8 to 1 decimal place. So U is between 3.75 and 3.85. And finally, T is between 1.835 and 1.845. And since I want the upper bound of A, I will need to divide the upper bound of the numerator over the lower bound of the denominator. And since the numerator is a difference, I'll have the upper bound of the first number minus the lower bound of the second number. So I will need to use the upper bound of V and the lower bound of the other two numbers. So 9.65 minus 3.75 over 1.835. And if I put this on the calculator, I will get 3.22 correct to 2 decimal places. In question 16, I will need the bearing of C from B, which is this angle here. To do so, I'll need to work with the triangle ABC, whose vertices are labeled. Let's label the sides as well. So side BC is A, side AC is B, and side AB is equal to C. And I'll start by using the cosine rule to find side A. So A squared is equal to 150 squared plus 275 squared minus 2 times 150 times 275 times cos 120. So A squared is equal to 139,375. A is the square root of this number, that is equal to 373.3, and so on. So next, I will find angle ABC, which is this angle here, and I'll do so using the sine rule. Let's go on to the next page. So sine b over 275 is equal to sine of 120 over the square root of 139,375. So if you cross multiply, sine b comes out to be 0.637 and so on. Angle B is the inverse sine of this number. This is equal to 39.6. So the required bearing is equal to 180 minus 39.6, comes out to be 140 degrees to the nearest degree. In question 17, I have this solid. I need to find its volume. Now the volume of this shape is equal to the volume of a hemisphere plus the volume of a cylinder. So the volume is half of the volume of a sphere, which is 4 over 3 pi r cubed. And in this case, the radius is equal to x. So I've got x cubed plus pi RH for the cylinder, so pi x squared times 20 minus 4x. So let's expand and simplify. So 2 pi x cubed over 3 plus 20 pi x squared minus 4 pi x cubed. I can simplify the x cubed terms, which is the first and the third. So v equals, the middle term remains the same, and I have minus 10 over 3 pi x cubed because I've got 2/3 of this term minus 4 of those terms, hence the minus 10 over 3. Let's make this into a single fraction. So 60 pi x squared minus 10 pi x cubed over 3. And I can take out a common factor of 1 over 3 and a pi to get 60 x squared minus 10 x cubed. And this is equal to 1 over 3 pi y, where y is equal to 60x squared minus 10x to the power of 3. Now I need to find the maximum value of y, hence I will use differentiation. So dy dx is equal to, and now I'm going to multiply the power by the coefficient, that's 120x, reduce the power by 1, so I've got x to the power of 1, minus, repeat, minus 10 times 3, go minus 30x. If I reduce the power by 1, I get squared. And to find the maximum, I will set dy dx equal to 0. So 0 equals 120x minus 30x squared. Let's factorize this. 30x, I've got 4 minus x, hence x is equal to 0 or x is equal to 4. Now x is the radius, cannot be 0, so I will reject this value, and I'm going to continue with x equals to 4. That's the value that maximizes y, hence the maximum value of y is given by y equals 60. Replace x with 4, of course square minus 10, 4 to the power of 3, and this will give me 320, which is my final answer. In question 18, I will start with the left-hand side and I will expand. So LHS equals to 40 plus 8 square root of x minus 5 square root of x minus square root of x squared, which is x. and then I will collect the terms that do not have a square root, that's the 40 and the minus x, and simplify the rest, so plus 3 square root of x. And now I will compare with the right hand side, which is this one. So let's write this down, compare with right hand side. Now the term that doesn't have a square on the right hand side is 21. So 40 minus x is equal to 21. X comes out to be 19. And the term that has a square root on each side is y square root of x equals 3 square root of x. I can cross out the square root of x, so y is equal to 3, and these two are my final answers. In question 19, I will rearrange the second equation to get either x or y on its own. I'll go with x to avoid creating fractions. So x is equal to 1 minus 2y. And let's substitute this in the first equation. So wherever there is an x, I will replace it with 1 minus 2y. So I get 1 minus 2y squared minus 9y minus bracket 1 minus 2y equals 2y squared minus 12. Let's expand. So 1 minus 4y plus 4y squared minus 9y minus 1 plus 2y. And let's bring the other terms to the left as well. So minus 2y squared plus 12 equals to 0. Let's collect like terms. This gives me 2y squared minus 11y plus 12 is equal to 0. Now I have a quadratic equation. I can solve this either by factorization or using the quadratic formula or even completing the square. I'll go on with factorization. So I get 2y minus 3, y minus 4 is equal to 0. So y is equal to 3 over 2 or y is equal to 4. Each of those y values will give me an x value. I'll substitute these into this equation. So x is equal to minus 2 from the first one. X is equal to minus 7 from the second. So these are my final answers. So let's write these down. In question 20, I have two similar solids. I'm given the volume of each one of those and the surface area of B. I need to find the surface area of A. In this type of questions, I like to create the following table. Now note that I have length, area, and volume. That's 1 dimension, 2 dimensions, and then 3 dimensions. And I have a scale factor, K, which is at the power of 1 for the length, power of 2 for the area, and power of 3 for the volume. Let's enter the detail, the numbers I have on this table. So for the volume, I have both values. And for the area, I have it for shape B as a question mark for the area of A. Now note that for the volume, I have both, so I can use this to find the scale factor. So what I will do here is start from 1836 times k to the power of 3. This will give me 4352. So k to the power of 3 is the big one over the small one. So k is equal to the cube root of this number. And my answer comes out to be 4 over 3. So now I can work out the area of the first one because the area times the scale factor squared is 1120. So the area is 1120 divided by 4 over 3 to the power of 2. This will give me 630, and this is my final answer. In question 21, I have these coordinates, and in part I have this transformation. This is a translation by 3 units to the left, so I will subtract 3 units from the x coordinate. So minus 9 minus 3, it's minus 12. The y coordinate will remain the same. In II, I have a third of f of x. In this transformation, you multiply the y coordinates by a third, so the 15 will become a 5, and the x coordinate will remain the same. Now in part B, I have 2 transformations on the cos graph. The original cos graph looks like this. The 2 transformations are indicated by the a at the front. This is a stretch by a scale factor of a along the y-axis, and since a is positive, it means there's no reflection. Now in the original cos graph, the maximum is 1, the minimum is minus 1. In our graph, the maximum is 2, the minimum is minus 2. Hence, a is equal to 2. Now to find b, note that this is a translation, left or right, but because b is positive, this is a translation to the left. Let's take one of the points on the original graph. Let's take the minimum. The minimum has x coordinate of 180. The translated one has an x coordinate of 90, which means that my graph has moved 90 degrees to the left. Hence, b is equal to 90. In question 22, I need to find the inverse function of a quadratic one. Whenever I have this case, I always need to start by completing the square. So f of x is equal to x minus, because I have minus here, and then I need to have half the coefficient of x, which is 4, square this, minus this 4 squared, and then I have the plus 5. So let's simplify. That's x minus 4 squared minus 16 plus 5. So it's x minus 4 squared minus 11. Now, I will change the roles of y and x. So here I should have a y. So when I swap the roles, I will get x equals y minus 4 squared minus 11. And now I need to rearrange to get y on its own. So x plus 11 equals y minus 4 squared. And then square root of x plus 11 equals y minus 4. I need a plus or minus at the front of the square roots. Finally, y is equal to 4 plus or minus the square root of x plus 11. Now, note that I have a domain for my function. X is less than or equal to 4. So the corresponding range of the inverse function is y is less than or equal to 4. This is because the range of the inverse corresponds to the domain of the original function and vice versa. So if y is less than or equal to 4, it means that from this plus or minus, I will only keep the minus. Hence, my inverse function is 4 minus the square root of x plus 11. For question 23, I'm given this shape. I am also given OA is 2A, OB is 2B, M is the midpoint of AB and N is the point on OB such that this ratio holds. So let's put all this information on the diagram. Now I need to find the ratio OP to PM, and the way we do these equations is that we specify a fraction for OP as a fraction of the whole thing. Let's call this lambda. That's a number, that's a fraction. And also AP is another fraction of the line AN. Let's call this nu. Now I'm going to find two roots from a starting point to point P and then compare these roots. I will start from O and go to P either directly or through A. And then I will compare these two vectors. So let's begin to go from O to P directly. That's lambda times OM, which is lambda times, and OM is equal to OA plus AM. Now AM is half of AB. Let's find AB first. AB is minus 2A plus 2B. Let's write this down, minus 2A plus 2B. Hence, AM is half of that, so it's minus A plus B. So this becomes lambda, 2A for OA, and then minus A plus B. If I simplify, I get lambda times A plus B. When expanded, this gives me lambda A plus lambda B. So this is OP, the direct root. Now, alternatively, I can go through A. So I'm going to do something similar on the next page. OP is equal to OA plus AP. So this is OA plus nu times AN. Now I don't know AN, so I'll need to find it. So AN is equal to AO, which is this one, and then I'm gonna need 2/3 of OB. So AN is minus 2A plus 2/3 of OB. This is minus 2A plus 2/3 of 2B. And if I simplify, minus 2A plus 4/3 of B. So if I go back to P, I get OA, which is 2A plus nu times minus 2A plus 4/3B. Let's expand and simplify. 2A minus 2 mu A plus 4/3 mu B. And if I collect the A terms and B terms together, I get 2 minus 2 mu A's plus 4/3 mu B. Now, in the next step, I will equate the coefficients of A, and I will also equate the coefficients of B. Now, let's color code this. The coefficients of A are 2 minus 2 mu from the second one and lambda for the first one. So I get, let's write this in blue, lambda equals 2 minus 2 mu. And then for the coefficients of B, I've got the 4 over 3 mu from the second one, and from the first one I have lambda. So let's write this down as well, this time in red. So lambda equals 4 over 3 mu. So now I will solve these two equations simultaneously. I'll use substitution. So 2 minus 2 mu is equal to 4 over 3 mu. I'll take all the mu's on the right hand side. So 2 is 10 over 3 mu. So mu comes out to be 3 over 5. And then I can substitute this value into any of those two equations. I'll go to the right, the red one. So lambda is equal 4 over 3 times 3 over 5, which gives me 4 over 5. Hence, OP to PM is 4 over 5 to 1 over 5, which simplifies to 4 to 1, which is my final answer. For question 24, I'm given that the sum of the first two n terms of a series is, so equals 4 times the sum of the first n terms of the series. Let's recall the formula for the sum of the first n terms as given in the formula page. So if I use this formula for the sum of the first two n terms, I will get 2n over 2 times 2a plus 2n minus 1 times d, and this is equal to 4 times n over 2 times 2a plus n minus 1 d. Now let's simplify it on each side. So n 2a plus, and let's expand, 2n d minus d equals to 2n square bracket, again let's expand, 2a plus n d minus d. Now I can cancel out the n's, so I get 2a plus 2n d minus d is equal, and this expands to give 4a plus 2nd minus 2d. Again, now I can cancel out the 2nd on each side, so I'm left with 2a minus d equals 4a minus 2d. Let's collect the d's on the left, so d equals to 2a, hence a is equal to d over 2, and this is my final answer.